When you break an ion chain or when you melt copper into liquid, the identity of the material does not change. You still have iron here and you still have melted copper. And so such changes are called physical changes. But what about burning of wood, or when you let the milk go sour, or when you let iron rust? These are different. We call them chemical changes. But what is so different about them, and what exactly are chemical changes? Well, let's find out. Well, chemical changes are when substances change into other substances altogether. For example, when you're burning wood, you get ashes, which is a different substance altogether. It's not wood, it's a new substance that's been created. When the milk goes sour, well, you get sour milk, which is very different from fresh milk, a new substance. And rusted iron, well, is not iron, okay? So that's what chemical changes are. We get new substances altogether. Here's another example. If you take hydrogen gas and mix it with oxygen gas in a spark, they will explode to give you a completely new substance, water. Again, it's a new thing. It's a chemical change. It would be wrong to say that water is hydrogen and oxygen mixed together. No. It's a new thing. It's not a mixture. We call this a chemical change. You might also say it's a chemical reaction. We say hydrogen is reacting with oxygen to produce water. Here's another example. If you take sodium, which is a squishy metal but extremely harmful to touch, and you make it react with a chlorine, a green gas, which is again harmful, you know what you'll get? You will get a completely new substance, table salt. That's right. And what's interesting is that although these two are extremely harmful, table salt is not. You put them in French fries and we eat them. So again, this is a chemical reaction. We're not just mixing sodium and chlorine. No. We're producing completely new substances. It's a chemical change. It's a chemical reaction. And just like how earlier we defined physical properties that you can measure without changing the identity of the substance, we can now define chemical properties. These are the properties that can only be measured or observed by changing the identity of the substance. For example, the ability to rust. That's a chemical property. You can only measure it by making something rust. And when you do that, the identity has changed. It's a chemical change. A new substance is created. Another chemical property, for example, is the ability to go sour. That's another chemical property. Flammability. If something is flammable or not. Explosive. And ability to react violently with chlorine. These are all examples of chemical properties, because when you measure them or when you try to observe them, you are going to change the identity of the substance. You're going to create a new substance. In other words, you're going to create a chemical change. Now, the last question we could be having is, are there some signs that a chemical change has happened? Are there some telltale signs that a new substance has been formed? And the answer is yes, there are 5 common signs. First one is sometimes when a new substance is formed, a color change happens. Other times, there could be a change in the odor. There could be a gas that is produced. Sometimes when a new substance is formed, it comes out as a precipitate. We'll talk more about that in a second. And sometimes there will be an observable energy change. Let's go through these one by one. Let's consider rusting. Iron is grayish metal, right? But what about rust? Well, it's reddish. So look, when a new substance is formed, the rust over here, a color has changed. So sometimes a color change happens when chemical changes happen, okay? Then consider what happens when your milk goes sour. Sour milk is a new substance and it has a different odor, which you can pretty much smell from miles away, right? So here's an example when an odor change happens. Okay. Sometimes when these new substances are formed, they can have a different state of matter altogether at room temperature. For example, when you pour copper in nitric acid, the new substance, which is nitrogen dioxide, is a gas at room temperature. It has color, and so you can see it. So look, the new substance is a gas over here. Sometimes when you mix two liquids, we're mixing two liquids over here, you know what you get? You get a solid. You get solid crystals. Actually, if you zoom in, let's zoom in over here. You are seeing solid crystals being formed in mixing liquids. This is what we call a precipitate. It settles down. And so look, a new substance sometimes precipitates out. And finally, we can have observable energy change. And when we say observable, we could have some light being produced, sometimes some sound is being produced, and sometimes when new stuff is produced, we have a change in temperature. For example, when you light a gas stove or when you light a candle, again, new stuff is being produced, and that produces a change in energy, light. When you have firecrackers, again, a lot of new stuff. It's a chemical change that's happening. You have light and you have sound, and there's certainly a temperature change that's happening. And glow sticks, when you crack them, it's a chemical change. New substances are formed, and what happens? You get light. But remember, just because you see the signs of chemical changes doesn't necessarily guarantee that a chemical change has happened. For example, when you're painting, when you're mixing color, well, there's a color change, but that's not a new substance. That's just a physical mixture. Similarly, when you put ink in water, there is a color change, but that's not a new substance. It's a physical mixture. Similarly, when we're boiling water, we see a gas, but it is still water. It is not a new substance. It's a phase change. It's a physical change. The only way to be sure that a chemical change has happened is to test for a new substance altogether. Like, for example, when you react hydrogen with oxygen with a spark, you can test that a new substance like water, which has its own identity, that has been produced. That's the only way to guarantee that a chemical change has happened. So putting it all together, chemical changes are when substances change into other substances, new substances altogether. We call them chemical reactions as well. And just like how we have physical properties which can be measured without changing the identity of the substance, we now have chemical properties that can only be measured by or observed by changing the identity of the substance. And these are some telltale signs that a chemical change may have occurred. Doesn't necessarily guarantee it, but these are some signs. Now, we can put it all together by taking one last example, because why not, right? Let's consider magnesium. It has some physical properties, like it's not magnetic, it has some melting point. You can observe or measure all of these without changing the identity of this element. And so these are physical properties. But it also has some chemical properties, like for example, it combusts with oxygen at high temperatures. This is a chemical property because in order to measure this or in order to observe this, you'll have to have a chemical reaction between magnesium and oxygen. And in doing so, you would have created new substances. The identity would have been lost. So it's a chemical property. Okay. Another chemical property of magnesium is that it can be corroded with acids. Acids can corrode it, right? And so if you actually put magnesium in acid, you can see that it's being corroded. And in doing so, it creates you can see these bubbles. That's actually a gas, and that is hydrogen. And you can test for it. You can test that this is indeed hydrogen. And this is how we know that when you put magnesium in an acid, that's a chemical reaction. That's a chemical change, because the gas that you're getting is a new substance altogether. So that's a chemical property, corroded by acids.